that a big
There you
screen
go.
you can see?
Yeah, that's just the big screen now.
Yeah, I'm going to make you a grid over here and just pop you up here a second. Sorry. If I'm looking the other way, I'm looking at my other screen. I can't really see you guys, but I guess you're here. How do I make this bigger? Oh, there we go. Sorry. Right, I've got you on over here now. Right, can everybody see the presentation?
Yep, I can see it, Slade.
Right. Okay, right. International Space Station radio by myself. Today's presentation, we're going to look at what is ARES, what kind of amateur radio equipment is aboard the space station, how can you get involved, looking into the future. And just note, it's not a how-to guide. This will take forever to go through how to do every little thing. What this is aimed to do is give you an appreciation of what's aboard the space station and how you can get involved. Then it's kind of up to you to figure out, well, you can ask me questions, but it's just basically just an overview of what the space station has to offer to get you sort of a bit of a head start. And then if you want to find out more, that's entirely up to you. So it's not a how-to guide, how to do everything, but it gives you an idea of what's going on that one. So ARES itself basically stands for Amateur Radio on the International Space Station, and its main aim is to inspire students worldwide to pursue interest in careers in science, technology, engineering, and math through amateur radio communications with the space station crew. And they learn about life on board the space station, how to explore Earth through science and maths, and opportunities for schools and students and teachers and families to become more aware of the benefit of human spaceflight and exploration and discoveries that occur on spaceflight journeys, and to learn about new technologies and with communications and space technologies. So the amateur radio organizations and space agencies around the world really, the USA, Russia, Canada, Japan and Europe sponsor the opportunity for providing equipment and operational support to enable direct communication between the crew and students around the world. And hundreds of radio amateurs operate around the world, work behind the scenes to make this educational experience possible. We have a team here in the UK, the ARES UK team, which is heavily involved in the Tim Peake business back in 2015-16. It's a popular hobby. We all know licensed participants operate communications equipment with deep appreciation for radio art. And ARES are created and managed by the International Working Group, including, like I said, all the Europe, Japan, Russia, Canada, and USA, and managed locally within them as well. So the goals of the ARES program, as what we covered, is to inspire an interest in science, technology, and engineering and math, and in STEAM careers among young people. Provide an education opportunity for students, teachers, and general public to learn about space exploration, technologies, and satellite communications. Provide an educational opportunity for students, teachers, and general public to learn about wireless technology and radio science through amateur radio. Provide an opportunity for amateur radio experimentation and evaluation of new technologies. And provide a contingency communication system for NASA and the ISS crew. So that's really important. Really, if shit hits the fan, then technically the ISS crew can use the ham radios aboard the space station to contact mission control if they really need to, and provide a crew with another means to directly interact with the large community outside the ISS, including friends and family. So radio contact with the ISS, so scheduled ARES amateur radio contacts are conducted either by direct contact or by telebridge contact. The method used will depend on the radio station equipment and experienced radio amateur volunteers available to support the contact, as well as the issues related to on-orbit crew. Basically, what that means is two main methods. A direct contact is where the ARES team would go to the school, for example, and set up a radio station inside the school, outside in the car park, set up antennas, and have a direct contact with the crew. In a telebridge link, there are several telebridge stations, mostly in Europe, but also in America, which will do all the radio work and then sort of transmit that by internet to the school, and then the school would talk via internet to the telebridge link and then the radio up. So for example, they could be doing a contact in America with an American school, but all the radio waves are happening in Europe, for example, which is good for us because it means that we can listen directly into that contact as it's happening with the telebridge station, because we can still receive the ISS as it goes over. Normally the Europe pass, it's normally a good pass for us as well. So whilst that is happening, we can listen directly into the crew who are talking to the students in America via the Telebridge link. And because the AREX program supports testing and installation of amateur radio stations aboard the ISS, astronauts have equipment available to automatically unscheduled ham radio contacts. It all depends on who's up there at the time to do unscheduled contacts. Some of them are, enthusiastic hams on the ground. Some of them just have the license purely because they have to have the license to operate this. So there's a few astronauts that will go up there and take opportunities to do random contacts, but others just do it when they really have to. Amateur radio was regular payload on the shuttle missions, beginning with STS-9 in '83. Owen Garriott W5LLF carried a handheld radio aboard the Columbia space shuttle, and that was called AREX, which is the shuttle amateur radio experiment. And that was the early doors really to amateur radio in space, and it allowed people to talk directly with the space shuttle traveling around the world at 70,000 miles an hour. And to later missions, they had voice packet and television aboard the shuttle as well in the later missions, and they could ask questions about experiments being conducted on the mission and living in space. And this is basically what they kind of do now on the space station with the scheduled contacts. And then a computer will take aboard during downtime and do automatic transmissions, and the students could eavesdrop on the shuttle communications and listen to things as well. So when they do an AREX contact now, it's really about kind of asking questions about all that sort of living and working in space generally. But we'll all start on the space shuttle. That's Owen Garriott aboard the Columbia, doing one of the first space shuttle contacts. He passed away, I think, last year as well. And his son actually was a private passenger aboard a Soyuz in, I don't remember what year it was, but I know Harry, who in our club, he had a contact with him, his son, who was aboard the space station, and he basically paid his way to the space station. But it was his son. Get onto the space station. The first amateur radio equipment was delivered in September 2000. An amateur radio station was established on board. Used by astronauts who licensed radio amateurs. Commander William Shepard, KD-5GS, made the first amateur contact in November that year. Just a couple of days ago, on the 2nd of November, marked the 20th anniversary of continuous presence in space by humans. So since that day in 2000, we've never had a day without somebody in space. So November that year would have been about 20 years ago. This month was the first radio contact. Most astronauts go to the space station, have a radio amateur license. That's kind of part of their rules of going up, because obviously, like I said before, the ISS could the amateur radio aboard could potentially be used as a backup scenario for communication. So they're all licensed, but some of them are actual ham operators on the ground. That makes sense. Some of them are just there because they have to do it. So contact the ISS. Some ISS crews make random contacts. Like I said before, normally after their sort of work time. The work time is normally 7:30 to 7:30 UTC. Space station work on UTC time. Because of all the ground stations around the Earth, you've got Russia and USA, they're all different times. So they just decided to work at UTC to stop any arguments. They operate 2-meter packet radio in unintended mode whilst they're not being used, and also using packet radio or SSTV. We'll go into that detail and more in a second. A typical ground station for receiving the ISS includes a 2-meter FM transceiver, 20 100 watts of power, a sexually polarized Yagi antenna, or successful vertical ground plane antenna. So go more of that. Receiving is really easy. We'll go through the frequencies in a moment, but really you can have a successful receive on a kind of just a mag mount. Even I've received Tim Peake when he was aboard on a mag mount on my car. It gets trickier when you want to transmit. You have to be a little bit more accurate on the transmit with your direction. That's when you kind of need things like the cross-Yagi antenna, things like the commercially built ELK or the Arrow antennas are the more popular ones for the satellite world, and not just the space station, but in general satellites as well, are your FM and your USB, LSB satellites, your linear satellites. So receiving voice and SSTV and packet you can do very easily. I've heard school contacts just on my collinear outside. It's the actual transmit that it becomes the problem. And when you transmit, so for the digipeater, for example, you have to be really accurate on hitting that. It can be quite difficult to get into the to the space station. But receiving is really easy. Like I said, you can just do it with a normal sort of antenna. It's a very strong signal from the space station. So receiving is really easy. We'll go to the frequencies in a moment. So voice and SSTV are 145-800 worldwide. Voice uplinks. Now a couple of different regions. We have the Americas regions and the Europe region, slightly different frequencies, 1449 and 145-20. That's kind of more important for the crew. When the crew are traveling and they're doing random contacts, when they go from the Americas and over to Europe, they have to manage to switch frequencies. Because of the band plan, they have to change frequencies. The VHF packet uplink and downlink is 15825. UFS isn't really used, and the new repeater as well, 14599 and 437. It's a crossband repeater, which was new early this year. Most AREX operations are split frequencies, so each station uses separate receiver and transmitter frequencies. Downlink is the earth station's receiver frequency, and the uplink is the earth station's transmitting frequencies. Each earth station can listen to the downlink frequency and transmit on the uplink frequency. Please don't transmit the ISS downlink frequency. When I'm doing AREX contacts with the schools, they don't use those uplinks. They use a secret uplink. I don't know what it is. It's for that people can't jump on it. So they use slightly different uplinks. When you hear a school contact, you will only hear the downlink on 145-800. So you only hear the space station side of the conversation. So if you're hearing a gap, it's most probably that's when the question is being asked. So you can't hear the question being asked, but you can hear the response back from the space station. That's something to take into consideration when you're listening. You won't hear the questions unless you obviously know the transmitter frequency, which you kind of won't if it's an AREX contact. They don't publish them. You'll only hear the response of the space station. So bear in mind, if you're listening to a school contact, for example, you only hear the space station side of the conversation. They normally publish the questions online prior to the event to have some sort of understanding of what they're asking before they answer it. Call signs. These are the main ones. They can change the different crewing on board, but the Russian uses the RS-0 ISS. Any one SS is the NASA one, and you've got the different European ones. Tim Peake obviously used GB1SS when he was aboard the space station. Again, depending on the crewing on board, it can change. And those are the main ones that you're normally seeing here on the packet and the SSTV. So let's go. What's on board the space station? We're really lucky that this year we have a new system on board. It's called the Interoperable Radio System, IORS, and that's a new Kenwood system on board, which is the D710GA. That's located in the ISS Columbus module, which is the European module, and supports 2 meter and 70 centimeters, and provides a higher output capability, 20 watts ISS operations, but FM and packet operations. Higher power capability allows near horizon to horizon signal to reception using simple handheld radios or scanners. And they've got a set of 5 different options of programming memories are on board. There's a Kenwood D7E in the Russian side of the space station. And again, supports 2 meters and 70 centimeters and provides high output power supporting FM and SSTV operations. So all the SSTV operations normally come from the Russian side. And again, there's programmable memories on board to make it easier for them. Numerous channels programmed into the radios, again, for the different regions. Like I've said before, as they pass different regions, they switch frequencies. That's basically what the bottom 2 paragraphs is basically saying. That's the new interoperable radio system aboard the space station. this was only flown at the beginning of the year. It was only installed at the beginning of the year. This replaced the old AREX that were aboard the Columbus modules. This DAO supports, as well as Packet, the new voice crossband repeater, which is brand new to the space station this year. There's going to be 4 units of these. There's going to be 2 flyable units and 2 on the ground testing units for any trouble finding. As you can see, it's been modified for space station use. It's gone through a whole rigorous testing to be able to launch. All the cables have been coated in fireproof and fire retardant coatings and sheaths. We've got the power box on the bottom there, the radio on the top. So all the radios are programmed. It's basically astronaut proof. No fiddling, very simple on and off at the bottom. So they're going to be 2 flyable units, and they hopefully next year we're going to fly the second unit, which is going to be exactly identical, and there's going to be 2 units on the ground for testing. But it's gone through a various check for NASA to make sure that none of this interferes with the space station systems, that it's safe to use, that it doesn't catch fire, and everything like that, basically. So that's what they're using at the moment. That's replacing the AREX system on the European side. But the Russian side still have their own radios for the SSTV. But that's what we're going towards. Like I said, we're hoping to launch. This was all crowdfunded, by the way, by members of the public. All this was raised enough money for it to be able to launch. All the ARES and AMSAT groups around the world put out a massive pledge for people to donate towards this. So packet operations, there's one radio in the ISS that operates a packet distributor. The Columbus, that radio there, the IRS system supports packet operations. Again, it's not a how-to guide. It can be quite complicated to get into. You can use different kind of radios, or you can use a radio and like a Bluetooth system connects to a phone. Any two ways of doing it. It can be difficult to get in. Receive is not too bad, but to actually transmit, again, you need to kind of be pointing in the right direction. SSTV operations from the Russian side, normally from RS or ISS, transmit JPEG images and uses the antennas on the service module, which is the Russian side of the space station. Clear Space Cam and SSTV software, and so that's on the, and that's quite a regular cadence really. That's kind of what they send out. That's good looking photos compared to what people receive. But they do like some NASA on the air. They will run different during like the Apollo era. They did all the Apollo 50th ones. They did a Curiosity one. So every now and then, and it will run automatically throughout the day. So as it passes, it will do it will scan. So people try to get the whole set basically. That's kind of what they send out. There's a HAMTV system on there. It took over 10 years of work to establish the amateur radio TV transmitter. Uses a patch antennas fixed on the meteorite debris panels on the Columbus module on the US side of the space station. And they were fitted during the construction of the Columbus module. And again, 65,000 euros to make that possible, all crowdfunded. And they've got a transmit DVB-S signals on those current frequencies with 10 watts of power. And the main mission of the HAMTV is to perform contact between the astronauts, the ISS, and school students, not only by voice but by now video. In addition, the equipment is capable of transmitting pre-recorded video 24 hours a day. This is a massive thing when Tim Peake was aboard the space station. It was used heavily by the ARES team here. For every contact they did with Tim Peake, he had a HAMTV going at the same time, so we can hear and see him at the same time. Have to note that this system is currently broken and is currently on the ground being repaired. We're hoping it to be flying again at the beginning of next year. So currently there's no HAMTV system, but that's what it looks like aboard the space station. It's a simple interface again. That's it's heavy astronaut Samantha Christopheretti with the HAMTV system aboard the Columbus module, and you receive it using a kind of like a satellite dish because of the high frequencies there. But again, it was used heavily when Tim Peake was aboard the space station. that's the kind of image that you got back from him whilst he was aboard the space station. He would wear a headset. He was using the old AREX radios during his contacts. Like I said, the new radios were only just bought up recently. There are 4 antenna systems deployed on the ISS service module on the Russian side, supporting the Kenwood radios. Each of the 4 antennas can support amateur operations in multiple frequencies and allow for simultaneous automatic and crew-tested operations. However, the 4 antennas allows operations to continue aboard the station should one or more have a failure. And 3 of the 4 antennas can be identical to each other, can support both transmit and receive operations on 270L and S band. They also support reception of the station's Russian HAMTV system, which they use during spacewalks. The 4th antenna has an 8-foot-long vertical whip used for support high-frequency operations, 10 meters, but there are no HF radio hardware on board the space station to support that at this time. And 2 antennas on the Columbus module currently serving the new radios deployed. Frequencies available and are 2 meters, 70 meters L band and S band as well. These antennas also support the HAMTV DAT transmitter. So, to summarize, you've got 4 antennas on the Russian side and 2 on the Columbus side, supporting the radios on board the space station. That is one of the radios, so one of the antennas prior to the installation on the Russian service module. That's Peggy Whitson during Expedition 5, way back when, 2002. She's currently since been back to the space station and commanded it again for the 2nd time, and did a long duration flight. Anyway, those are one of the antennas and the cabling involved. So as of 22nd on 10th, it's an American date form, we have on board the Columbus module, the new Kenwood IO, the interoperable radio system, Kenwood D710. When that was the packet system is active. So I said they've got the new crossband voice repeater and the packet system. At the moment, only one of them can be used at a time. The plan is when the other system arrives on board the space station next year, the hope is to have packet system running and the crossband repeater running at the same time. So that's the hope in the future. But at the moment, if only one system aboard the space station, we can use one at a time. And coming up, we've got a launch of Crew 1 of Dragon from SpaceX, and they're going to no score events to take place until that arrives and they finish their 2-week standard orientation period, because they like to use the radio for other operations during that time. And the service module is usually off, but is turned on to support Russian SSTV, which happens quite frequently throughout the year. So, what do you need to listen to the ISS? So, like we mentioned previously, any almost 144 megahertz FM rig will receive the ISS. We can even use a more general coverage VHF scanner and an external antenna. Like we said, the simpler the better. A quarter wave is ground plane as a high angle of radiation and works well. The large 144 megahertz collinears are not as good, but like I've said from previous experiences, the space station is pretty loud on receive. You shouldn't have any problems really. Like I said, I've used handhelds, I've used back mounts, I've used collinears, and I've received it all the time. So I think that's, pretty damn good. And the UK we use 2.5 kilohertz deviation FM. You also transmit using a wider 5 kilohertz. So most things can be switched between this. So like we covered the antennas earlier on, the more popular antennas for the sort of Yagi types are the elk and the arrow. You can make your own using tape measures if you really want to and things like that. But the commercial ones are the elk and the arrow. Those are the popular ones against the guys doing the AMSAT stuff who are, especially if out portable, they're very, very light handhelds. Like I said, any FM rig, I've used Beofangs in the past to receive. I've got my Kenwood that I use as well. And in my base stations, I've got a Icon 910 as well. But like I said, any FM rig you can just use to receive. Most of the time, the space station is operating in automatic mode. Like I said, the AREX packet repeater, the new voice repeater, and the SSTV. I said we've gone through the frequencies before, and then with the score contacts, it'd be on sort of manual mode. Go onto the AREX website, AREX Twitter to get alert to when there's going to be. There hasn't been a lot during COVID, they've tried a new online kind of system during COVID, where they've used the rate like a telebridge link, but then internet as well. So they've kind of had to adapt the way that they work during COVID because they couldn't have school, gatherings. And also they use split frequencies as well when they do the CQ calls random. Just remember to activate your repeater shift to ensure that you reply on the correct frequency, so you are not transmitting on 145.800. It's split frequency, and obviously it's a moving vehicle, so we've got Doppler shift around 17,000 miles an hour, about 250 miles at altitude, 51 degrees inclination. And so we have Doppler shift where a frequency of 145.800 to look at 3.5 kilohertz, high-end frequencies. So when the ISS will approach your location, within a 10-minute pass, the frequency will move lower, shifting the total 700 degrees down. So you have to remember to tune as it goes as well. I normally have mine on my handheld. I normally have it set up in sort of blocks, so I can just go down, or you manually tune it. Again, that's the kind of only thing you're really worried about when you're receiving is the Doppler shift. But again, as it says there, you can have it left at 1.800 and you will still hear it. But it's better to follow the shift as it goes. So looking into the future, so we've got AREX. So we're hoping in the future that ARS/the AMSAT groups is poised to support human spaceflight endeavours beyond low Earth orbit, including the Lunar Gateway. Gateway operations will be more likely autonomous satellite with occasional human operations. I'm going to employ hardware operations and education infrastructure to on the ISS. The weak signal long path length challenges are achievable and have been previously demonstrated by the AREX and AMSAT teams, including receiving data from Voyager, Cassini, and Venus radar and several lunar missions. And recently, the Chinese launched Longyan 1 and 2, orbiting the moon, with good receiving results. And currently the AREX and AMSAT teams are currently working with NASA on the Gateway. It's going to look kind of like that. So Gateway operations are going to be similar to space station operations as such. So it will enable students and amateurs alike to contact the crews that are orbiting the moon and potentially have conversations with those astronauts on the moon. Again, we're going to have similar kind of things like packet repeaters, SSTV, voice, all those kind of modes, and other experimental modes as well to looking into. The likelihood is that that's going to be on a gigahertz frequency because of the distance involved. They are looking into a 70 centimeter version as well, but primarily it's going to be on gigahertz. So you're going to kind of need sort of dishes and things as well to kind of receive. But the idea is to use the kind of similar to the space station, but on the moon. And that's really what they're looking into. And the first part is that are hoping to launch around 2024. So they are at the moment early design and discussion stages, and they're hoping by next year they'll have a kind of a set plan and begin the really sort of building stages of that system. And it really is going to be a sort of an integral part of the design of the Gateway as well. So it's an extra thing. NASA are really involved within this. So we're going to kind of most probably build the antennas, post it in with the Lunar Gateway. It's going to become an actual part of the design plan overall. Again, it's going to be sort of two phases. Phase one is going to be the more simple operations, and then phase two, the more experimental operations aboard. It's kind of got all I've got at the moment.